start recording. Okay, so here we are. Uh, I actually think, Marinho, that this is already done for the body when the body is not empty, right?
Uh, yes.
So we should be able to just do declaration and put a guard here to make these two things separate instead. What do you say? So
Uh,
head, body, and then there's a when I think body something something empty list or whatever.
can't you just put an empty list in the pair match?
Can I? Oops, that's also not what I want. Like this, but I don't think that's how you do empty stuff on
List.empty maybe or something.
better match empty list or camel. Okay, thank you very much. No, it is like that. No, wait. This is the question. No, this is. Yeah, I don't think this is how it works, actually. I think this is an OCaml thing. Actually, maybe it's even a Haskell thing because this is not a data type like a raw data type. This is a record, right?
The expected type is a pair with a T and the lib machine cell
No, no, it's complaining about
T.
this.
Okay.
Let me put this larger. Expecting that and then set something else. Yeah, you see, because this is a record, I think we don't have a choice. We need to use a guard for that. See?
Okay.
Even in Haskell, maybe. I don't know the extensions. Maybe there is an extension that if you have. Uh, I have an idea though. I don't know where I'm getting this intuition, but what if I do this or something? Well, that's not how that works. I need to use a guard, I think. There's no way around it.
That doesn't feel right, but let's keep it like this for now.
Oh, can I ask that question maybe? Uh,
You wanna see if that thing is empty? Just put the empty clause there on the
you
body.
mean there? You mean here?
Yeah.
That's what we just tried. Didn't
Oh,
work.
right, right. It needs to be body
But
equals empty
yeah,
because that's
but you
a
need to
record. That's a
yeah,
record.
you need to put yes, you need to put the
Body
name.
equals there, like
Yes.
this. Okay.
Mhm.
Yeah.
Then it's complaining now about the return type. That's correct. Okay.
All right.
Now we can go back to here. So, do you remember if we did queries at all? Because I think we did half of it, maybe. I
We
don't.
started working on it. Let me check the last commit.
I think we just don't have facts because, well, we jumped this page.
Not Lycium, Karuta.
That was Gnome angry with you, Lemons.
That's what.
That was
And code
Gnome
gener-
angry with you.
Who is agreeing with me?
Gnome.
Oh,
No,
Gnome.
angry with you.
Oh, angry with me.
Yeah, I did the noise. Gnome noises.
Ah, oh yeah, yeah, yeah. The sound, yeah.
Whatever.
Yeah.
Yeah, I think we do have the code generation for queries,
Okay, so it's
actually.
just facts. I have a question before we even begin, which is I have a suspicion that this entire thing will be a fold process. Am I right on that?
A fold process.
Yeah, at some point you're gonna
Uh,
get the things like the arguments. I don't remember the nomenclature.
yeah. You need to step through the arguments of this predicate assertion.
Man, this function is probably 250 lines long. It's kind of insane. We really should break this down. We really should. 120,
Eh,
and we will go all the way down to what? We'll choose 79, so it's like 179 lines of code.
by the way, I'm thinking, given that there's this proceed at the end, I think that the idea here is to like just execute all the facts before running the program, which means this is something we can probably do a little bit later, I imagine, but we will probably need to like reorder where the code gets emitted so that all the facts appear first and
Yeah,
then the
that actually
query
makes sense. That actually makes a ton of sense.
and then the other predicates that are not facts.
Yeah,
Because if you do it like that, you're going to run through the codes of every fact, and then you will run the query at the end, and then the predicates exist, so you can call them.
yeah, no, that makes perfect sense. But that's definitely a second step on this process here.
All right.
Okay, let's do it. So the first thing that I noticed that when we did functor, we did this thing. Uh, right. And why does that matter? Because it matters because okay, maybe that's a little bit too much. Actually, it's fine. Why that matters? Because we need to get to the get structure, right? Which is here as well. Does that make sense?
Makes sense, yes.
So we do the same thing, I guess. Same thing. Boom. Where is that thing going on? So we need to unwrap this thing, I guess. So name f elements and arity. I'm hoping that's how you do that. That's not how you do that. I forgot. Again, the syntax. Do I need to do parentheses on this? Also no.
Uh,
Oh, probably I need to do head equals.
yeah, you need to do head equals.
Okay. So we get the register value, then we create the get structure. Seems correct to me. Then we add that to our compiler and store stuff. Then we start calling the arguments, which is also the thing that we're doing here. Right? So I think that's also what should happen in here. But we are doing emit functor argument, which has a unify variable thing, as you can see.
I can see.
Uh, well, but we are using that in which circumstances? We're grabbing the elements and we're folding the emit functor argument, which calls emit argument, which is this one. And this one is just checking if it's a variable. In this case, the x will be a variable, right?
It is.
If it's a variable, what we're going to do, we will see if this variable was found before. Does that matter for us in this case? The answer is
It matters because this is all a
yes.
single fact, so everything is in the same scope, right?
Yes, no, it matters because in the first time we do the y here, we do unify variable, but the second time it appears, we actually do get value on it. So this distinction is important as well. Uh, this distinction is important as well. Another thing that I noticed, we first there is a name for this tree traversal because we are doing this like the first layer and then we are going deeper. You see
Uh, that's not really what's happening at all, actually.
how it
Oh
isn't
no,
though?
it is. It actually is.
Yeah,
Okay. That's bread first, because you are going through the
yeah, that's the name.
entirety of each level before descending further.
Yeah, so breadth first. Our fold, does our fold follows that? Are we doing breadth first or are we doing depth first?
We're folding over
The elements.
we're folding over the elements. Are we not? I'm pretty sure we are doing a. Oh, this is a fold left. Hmm.
Yes. But here's the thing though. The functor emit functor argument. Oops.
No, this is red first because this is going to fold over the entirety of the top level of the functor, right?
But how
But
do we
then,
know it is
but
not
then when we do
doing?
the emit instruction, we are actually, or not when we do emit instruction. There's a there's a finger tree in there somewhere that we're adding the nested elements at the end.
Hmm.
Although
Okay.
I don't remember where exactly we're doing that though.
Yeah, but I think this is already wrong, and let me explain why. Because the first time the y appears, we unify variable, which is the one that we use variable here. Which one is called variable? The first one. So this unify variable here. But the second time this appears, which is here, we're doing a get value, but there's no get values in here. You see,
Hmm.
which kind of means that uh, that's a little confusing. How are we generating code for functors and they are not facts?
Because functors can appear as arguments to predicate calls.
Oh, okay, that's true. Okay, that's why. Okay, but am I right in saying that there is a um, huge enough difference between emit? We should have something to like emit a fact argument.
Here's the problem though. Get value takes two arguments, right? It takes two registers.
Yes,
Didn't we have a similar discussion about this when we were working on the queries? About two instructions that are basically the same, but one takes two parameters, two registers, and the other takes one?
I think we had the discussion about the put variable. Let's see the code for get value. Oh, it calls unify. We can't cheat then.
Get value calls unify, but what about what was the other one?
The other one was put variable.
Yeah, but that's for queries though. This is not a query. This is a fact.
Yeah, no, but the other one that we were discussing last time was put variable. That's what I remember.
Uh, yeah, it was put variable, but there's another instruction that's just like put variable, but it
Ah,
only uses one register.
okay. So I don't know. I
I
don't
think it
remember which
I
one.
think it was set value actually.
Set value. Let's go. I think that's the one down here though. Oops, too much. Set value you said.
Yeah,
So
set
let's
value.
scroll up all the way. Set. Did we implement that?
I'm pretty sure we did, but it's like very early stuff.
Oh, here it is. Okay, set value is being used down here. It actually has one argument, yes. And you're right. Doo-doo-doo. It's the same thing, but instead of doing with two things, it's doing with one.
Essentially, yes.
Cool. So what's your plan? Try to analyze that piece of code to see if we can get away with set value instead of get value.
Well, it's not set value in this case. And the idea here is okay. We need to look at get. It's get value, right? Or is
Yeah.
it get variable?
No, get value.
Get value. Okay. We need to see if there's. We need to see if there's something else that takes one register but is. Hmm. This calls unify. Is this the only instruction that calls unify?
I don't. I think so actually. I think this is the only instruction that call. No, wait. I may be mistaken. Wait a moment. Maybe there is another one. Uh, I
Get
think oh,
structure.
here it is.
Oh, but this instruction is modal though.
What do you mean modal? Oh, there's a mode thing. Okay.
Yeah, I think we can't actually get away with that here.
Okay, even more sad. So that means that we're gonna have to re-implement emit argument then. That's what you're saying.
Yeah, because this is the only case where we're forced to use two argument instruction.
Yep. Okay, so let's accept our fate and move on with it. What about then just copying most of emit argument and putting into emit fact argument? Because there's no need for this sort of modularity here then, right?
There isn't, you are correct.
Yeah, so let's go back
Sure, we
to.
can do that, I guess.
Yeah, later we can try to figure out if there is a way to improve that even further.
To go even further beyond.
Yeah. Uh,
That's a reference, by the way.
well, uh, no shit.
You just assumed that by default now, Marin. By
No
the way,
shit.
I have a announcement to make, but I'll do that after we stop recording.
Alright.
Oh,
It's a
announcement.
proposal, actually.
The
Okay.
people watching this in the future will be very
They'll
curious,
be
Mageta.
they'll be curious, yes.
They will be very fucking curious, but okay.
Yeah, it's just there's a game jam, right? I don't know
Yeah,
if
the
you
one
guys
that you
know
just
about
sent in
that.
the recommendations.
Yeah, that looks fun actually, and I know how to compile stuff, so it's not impossible. We can do it.
We can do it.
And there's a money prize.
Damn!
Yeah,
Oh, I see. A Sega Saturn game jam.
yeah.
That
Pretty cool,
sounds
huh?
interesting and
It is because
unusual.
it's a different architecture, so we will have to learn a couple of things that are like it's the 90s again.
Amazing.
Yeah,
So let's discuss that after this, but
sure. If the thing is already there, then we need to do get value on it. So how are we gonna get the second thing, Marin?
How are you gonna get the second thing? That's hmm.
Hmm.
Oh, I see. In this case, we're doing the get value, and this is for the arguments, the direct arguments of the fact. So
Actually,
the second thing
I
is
haven't even paid attention to that. One moment. You're saying that the get
okay.
value is getting the x5, which is the first appearance of y, which is this thing, and we are also getting the a3. What the heck is a3?
That's the same as x3, but in this case it's because this is the third position of the fact.
Third position.
Yeah, the
Oh,
first argument
here.
of this fact is f of x, the second one is age of whatever, and the third one is just y.
Yes. Yes, yes, yes. Is that how
Y
the
lemmas.
rationale should be then? Should we add an index for the fold?
Well, just the top level fold needs to treat this especially, right? Because only the top
Uh,
level will deal with the actual argument registers.
yeah, but
Yeah, and we will need an index because,
yeah, but this is OCaml though. They don't have
And
that
this
function.
needs to change, and we need to do the register allocation differently as well because we have to skip the first three registers, right? Well, however many registers the fact takes as arguments.
Aren't you already doing that?
We are. I'm not sure if that's before or after though. The Oh,
No,
this is
we
for queries
yeah,
though.
but we
This is
are doing that what you said, I think. But
yeah,
in
yeah.
queries, we just need to do the same for for facts. So declaration, same thing as down there. So head body equals empty thing. and then we just do something about it. I'm gonna guess that we're gonna do mostly similar to this guy, but we actually need to do a little bit more stuff. So, what do we need in here?
Oh, the head is a functor, right?
Yeah, arity and elements. Actually, don't need the elements on this. Maybe not even the name on this.
Just grab it and name it F, I guess.
Grab it. No, I don't need to name it F. I have head.
Oh man, check this out. Bene, we're getting 20k alerts missing blah blah blah. What do we do? Ah, mute that shitty alert for now. Right? I just said. I just said Friday evening mood. That's it. No,
Okay.
no alerts. No sev ones. That's it.
God damn.
Savage.
A declaration has a head, which is a func. Why can't I just pass a head here?
Because you are not binding the name
Oh,
head.
like this. Uh, and then we generate the code, but generating this code should actually be inside a declaration again. So we need to do AST, declaration,
Just do as, well,
like
you don't
that.
need that because
Oh,
decal is already.
mm-hmm. That's it?
I think so.
Okay, so
We
now
can
we jumped.
yeah, we can revisit this if it turns out to be wrong.
Okay, so now going back to get value. Actually, let's read from the start. What are we doing? We grab the element of the fold, so we're grabbing one of the things in here. And we're trying to find its register, correct?
Yeah.
Let's pick this x as an example here. So that means that we're gonna do a variable, right? So variable. We check if the name of the variable we know before. In this case, we're gonna do none, correct? And then we use
Mm,
unify variable, which is this one.
yeah.
Cool. Next up, we're gonna do the h. So it's gonna go to this catch-all here, right? And then we need to do the get structure thing, which I just typed to remember myself to do it, but I forgot. What do we need for the get structure again? We need the
Get
name of the thing.
structure needs the name of the thing and it needs a register.
Wait a moment though. That means that it needs to be a functor.
Well, if it's a get structure, it must be a functor.
Well, but that's a problem because then this cannot be a catch-all. Uh, okay, so what types of things can we have in here aside from variables and functors anyway? Do you know?
Just variables in functors.
So in that
Because
case,
we could
the
have an atom, but an atom is just a functor of arity 0.
reachable emit fact argument, and this one will be functor namef and whatever else we're missing there. Let me copy the other get structure that we have here. There it is. Here we are. Boom. And you also need the arity, of course. We don't care about the elements, right? Because it's a breadth first. Breadth first.
Uh, we do need to care about the elements, but not at this level yet. I don't think so.
Okay. Okay, then we do this instruction, and we add it there, and then we proceed. Next up is going to be a variable again. But this is the first time we're seeing y, which means that we're going to go to the none case again, which means unify variable again. Awesome. Next up is a, which is... No, actually not that. It's hyx6 because this is a functor again, right?
This is a functor again, yes.
So we're gonna go here again, and we're gonna do. That's wrong. Do you agree?
Uh,
We're gonna do a get structure on it, but we should not do that. The get structure is
mm,
actually in here, if you think about it.
yeah.
Okay, so how are we gonna do this thing then? And I have another question. Why in these functors inside we did unify get structures and unify variables, as you can see, and when we reached this one, which is one level deeper, we actually do unify variable again. What's the rationale in that?
Because of nesting, you need to put this in a register first, but you don't you don't want to clobber the registers that you are allocating at the moment, which are the arguments, right?
So we need some sort,
Although
in the accumulator we need some depth, I think.
although do we actually need to do that? Yeah, I think we should. But yeah, we need to. We're doing this somewhere else already, where we have a finger tree that we're using as a queue, where whenever we reach a nested elements that we need to process, we put it at the end of the finger tree, and then after we process the current element, we pop an element from the left and work on that next.
Okay, so term q. Oops. Wait, are we not using the term q? Oh, terms. Okay. Something like this.
Yeah,
So what's your idea?
basically, whenever we reach a case where we're not like whenever we reach a struct which is nested within another struct, and that outer struct is an argument, instead of instead of allocating emitting the code for the struct, we put it on the queue and we do a unify variable instead.
No, yes, but how do you plan on using the queue to know the depth of the thing?
We don't have to.
We
Just by
don't
using a
have
queue,
to.
just by using the queue, what's going to happen is, okay, at the top level, we're going to process all the elements of the top level first, and we're going to put all the elements of the second level in order at the end of the queue. When we start processing the second level, we're going to put the nested elements of that at the end of the queue as well, which means they're going to be processed after the current level is over.
Man, I think I got the general idea, but I don't see how this is gonna translate to our code. Let me give you an example. I think it's easier. Do you okay? So far, I know this code is wrong, doesn't compile. That's fine. But do you? We are at this stage of the process, right? Agree
Right?
on that?
Agree?
Yeah. So we need. This is the order of the instructions that we need to emit. How are we gonna know that this thing is a functor, but is a functor that is not on this level of the f and the h? It is, well, these two, because f appears twice, right? So this f and this h.
Right.
How are we going to know that given what the information that we currently have at this point here? We are doing this guy.
We're doing this guy. That means we are in that outer fold, right? Iterating through the arguments,
Yes.
where we just emitted the code for the get structure ace2 and the first unify variable, right? We already did that. And then we're going to get to emit the next instruction. We're going to say, okay, is this a functor or a variable? If it's a variable, we can just do unify variable, or yeah, we can just do a unify variable as usual.
Mm-hmm.
If it's not a variable, if it's a functor, we need to see which register was allocated for it, do a unify variable for that variable, for that register, put the functor in the terms queue, and then we just keep going. And then after we finish the loop that iterates through the direct arguments of the fact, we iterate through the queue afterwards.
Ah. Okay, that middle to second part, I got it. I just don't know how you're gonna detect this thing
Just check
to
if it's
start
a
the
variable.
process.
You just need to check if it's a variable or a functor, Lemus.
No, wait. Then I am misunderstanding something.
Because the term that we're iterating through is not this one, it's actually the one on the bottom.
Ah, you're completely right. We are doing if, h, and y now, correct?
Yes.
And then later on, what we're gonna do is the x.
No, the x
No,
we can do immediately because it's a variable, but the f of a nested inside of the age, that we need to put in the queue and do later.
wait a moment though. That means that when iterating through the like we have the elements here, right? This functor is this h,
Yeah,
and there we have both the y and the second guy, which is a functor
yeah.
in this case. We have them available. We need to fold them in here immediately.
No, if you fold them immediately, this is not breadth first,
No,
it's depth
no,
first.
not fold them immediately calling this function. We need to make another function
No,
that does that.
we can just put it in the queue and then. Oh, actually, we will probably need another function that steps through the queue afterwards.
No, but if we do the queue thing that you said, we're gonna have this thing out of order, right? We need to put the unify of the y now.
No, 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 no. We check if the direct arguments of age are a variable or a functor. If it's a variable, we emit the instruction immediately. If it's a functor, we put it in the queue and just do a unify variable.
I think I am not, I'm not explaining myself correctly. Let me backtrack a little bit, okay?
Okay,
When we call this function, emit argument, fact argument, down here. So this is gonna be this thing, correct?
correct.
Yeah. So here's my thing. These elements are on the like there are this list here. Agree?
Agree.
Okay. Then let me actually remove depth from here because I think we are gonna use the queue. You're right. Then my question to you is: we are pattern matching and trying to find the registers for F, H, and Y, right?
Right.
Okay. Let's go through this first example here. We found a functor there. We're gonna put a get structure there, and so far so good, right?
Yes.
Okay. But notice here that we don't have the elements of F available. We don't have this X on hand. So okay so far?
We do need to care about them at the moment, actually.
Okay, so that's my point. Thank you. So we do need to do a fold here.
We do. And then inside of this nested fold, we check, is it a variable or a functor? If it's a
Yes,
variable,
yes, that's what I'm talking about, making a separate, smaller folding function for this fold here. That's what I meant.
emit nested fact argument or something.
Yes, emit nested fact argument, pass the things, store, and pass the elements in, and that's it. Actually, I think we need all of these. Okay. Actually, we don't even need. I think we do need these as well. This is gonna be nested. So if it's a variable, what do we do?
Well, we just emit unify variable.
We don't do a lookup, right?
We need to do a lookup to see, okay, this variable name is allocated to register x4 or whatever. And we
No,
just
but we are doing
emit.
that in here.
Yeah, we're doing that in here already.
Yeah, but what about
So
this lookup?
find lm registers. lm is an ast.t. Oh, right. This is to decide if we're going to do a unify variable or a get.
Value.
Hmm.
Yeah, because look here. I don't know if this is correct, by the way. I'm just looking at the example here. So the first time y appears nested, we do a unified variable. The second time it appears, well, the second time it appears for the
Mm,
code generation.
yeah, no, but that's different, Lemos, because in the first case, it's not getting a unify variable because it's the first occurrence. It's getting a unify variable because it's a nested occurrence.
Okay, okay. But well, in that case, what we need to do is to just do a unified variable immediately then.
Yeah.
Okay, so we do that. We don't need variables anymore there. Do this. And we actually don't need variables here. And we can just return compiler there. Do we care about the name of the variable?
We only care about is to see which register it was allocated into.
Well, in that case, in here we don't care about it. Oops. There we go. Okay, if it's a functor though, nested, we need to do the queue thing. I have
Yes,
another question.
okay.
Are we going to use the same queue that we were doing the same trick in the other place? Does that matter?
I think we can because this is inside of a fact, right?
Okay, so grab terms. Yeah, this is inside of a
Yeah.
fact.
Facts can only appear in the top level of the program, which means that the term queue will be empty when we start working on the fact. So I think it's safe to use it.
Okay. Okay, so we need to do the operation with terms if it's a function, right? What are we going to put inside the terms? Here it is.
We need to put the same functor that we are looking at right now.
The same functor you said, right?
Yes.
So as functor, oops, that. Then we need to put that in here. Let in uh, f. What the heck is unused variable terms? Ooh, I did bullshit. This is the problem with having such a long fucking function. This is the a long ass function. F, and I lost the cons of the freaking course. Uh,
Do you like omelette, Lemos?
like what?
Omelette.
Yes, I do. That was a pretty random question, so I'm kind of intrigued. And in here we put in a phi. What are we gonna unify with? Register, I believe.
Yeah, the register.
Oh, we're gonna do that regardless. So why not just do it like this then? Don't need you. We don't care about this. So this is just add instruction. And
Can't we pull the add
oops.
instruction out of the match?
Uh, the answer is the. It depends. The match would have to return the new compiler at least.
Oh, I see. I see.
What do you prefer?
Uh, I kind of want to put the add instruction before the match, and then we can just return the compiler after the match because we're going to do add instruction. We're going to add a unified variable regardless, right?
Yes. Okay, that's fine as well. Uh, there it is. In. If we do this, we need to return the. Man, can I do this? Or something? Is that a thing? Can I do that? Damn. Uh, in here, this is just
Result
boom,
with terms, I
boom.
guess.
Well, in
Oh,
that case, I'm
compiler
gonna
with
even gonna
terms.
inline that. Boom. There it is. Okay, that was not so bad. Uh, okay, so then functor now looks like this. This is the upper level functor. Is it correct now?
Let's see. We do a get structure. We emit the nested fact arguments, and then we add the instruction. No, that's backwards. We need to do the get structure first, and then we do the nested arguments.
Get structure first, then nested arguments.
No, no, but there you are just constructing the instruction. You're not actually adding it. You
Oh,
see?
you mean this?
Yeah, yeah, yeah.
Uh, uh, yeah.
Compler.
Com there it is. I think that's it, then we fold.
Then we fold, yes.
Pretty cool. Okay. Let's finish variable on the top level now. This is a get value.
This is the get value. I think it's always a get value, actually.
Always a get value. Okay, awesome. So we can remove this thing. Uh, we can then also remove this. Say by. And the instruction you said it's always a get value, but get value requires two registers though, and we don't have those at the moment.
We have the index, though, don't we?
What do you? Oh, the index you mean of the fold?
Of the fold, yes.
Uh, let me tell you a very sad story. Uh, Magetta, you there? And the answer is no. Uh, so here's the sad story for you, Marinho. There is a function here that comes in the standard library, and I don't remember exactly the name.
That's F
Uh,
sharp, though.
exactly, and that's why it's sad.
Oh, it exists in F sharp, but not in OCaml.
Yeah.
That is sad, yes.
Let's take a look here to see if I'm not insane.
I wonder
Fold.
how much work it would be to just use streamonas, actually.
Three what?
Streamonas. Let me grab the thing. It's a link. Where's the here?
Oh wait, I lied. Actually, they have MapI, which is also unavailable in OCaml. But I don't think they have foldI.
That is pretty sad.
Yeah. They haven't figured this out to this day.
I posted a link in programming.
Let me check. Open. Streams. Stream fusion. Stream fusion for having an index? What do you mean?
Because with the primitives that exist in this library, you can just do a zip with a range,
No, but
basically.
that we can do as well in standard library of OCaml, I think. I don't know if we need that. Maybe I'm tripping, but let's see. Zip.
I mean,
Ooh. Okay, I already searched this before, 100%. Oh, it's combine. Okay. Okay, so we have combine,
but
list,
combine
range.
means, but combine will force us to allocate an entire other list just to hold the numbers from 0 to whatever.
Well, yes, the fusion thing does it lazily.
No, actually, this uses a bunch of metaprogramming. You know Camel, yes, to do optimized code generation. Um, like it's not laziness in the Haskell sense. It's more like it transforms the code into something that avoids intermediate allocations.
Oh, so like in place stuff.
In some cases, yes.
Okay. Uh, yeah, but I don't want to add a dependency for that right now, though. I'm a little bit. Oops. That's kind of what I need, actually. Oh, but I will have to do this myself. Man.
I wonder if
uh,
batteries has something for this.
ooh, that's actually a good thing. And also sequence. Go and look into batteries. I'm looking at sequences.
Okay.
Oh, they have sequences have iter I actually. So at least the pattern is here. Let's see. Fold left I. There it is. Success.
Okay. We have this library, right?
This is standard,
Okay.
but we're
Then
gonna
there
have
we.
to convert the list to a sequence in order to use it. Okay, why are we doing that? Oh, because the emit fact argument function cannot we can't use this with a list. We need to use this with with a sequence. And then because of course oh no, actually doesn't matter. So this is seek left I, and the counter comes after the accumulator. So this is definitely the accumulator. Then we're gonna have a counter, which is actually I'm gonna call this index, and this is an integer, and there we go. Okay, now we
Uh,
have the number.
Now we have the number. I just noticed actually the get structure instruction is wrong. We need to use the number, the index as well there.
Wait, where? Sorry.
Line 188, we're using register, which is whatever register we allocated for the thing, right?
Yeah, no, but we need this needs to be a register. This is a number. We need to create a register now.
We do, yes.
Okay, so what would that be?
Uh, I think it's cell.x, if I'm not mistaken.
Yep. In here we use the index register.
Why don't we call this arg register? Because that's what it
Sure,
is. Arg or argument, I guess.
sure. I think the order matters in here. So this the R comes first. Oh, second. Sorry. And this needs to be probably in like this. Is that it?
Uh, Get structure.
We're not done yet though. We need to do this part.
We do. Uh, Actually, no, that's easy. This second part where we do the nested thingy, the f of a in this case, is just iterating through the queue.
No, yes, but I have a question for you about that.
Okay,
How are we gonna know how many elements we're gonna pop from the queue?
it's just one at a time.
Yeah, but we're gonna do that until it's empty?
Yeah,
But I have a feeling though, these terms thing that we are reusing, this we are using somewhere else. How do you know you're not popping something that you shouldn't?
because we are emitting the code for a fact, right?
Yes.
But a fact can only happen at the top level of the program, right?
Also yes.
It's basically an invariant of the compiler as it is right now. That
What if you have two facts?
no. It's an invariant of the compiler that for each top level,
Oh, it's an invariant of the compiler that for each top level declaration we're gonna have empty terms.
yeah,
Okay.
because the terms are there in order to do more stuff in the same scope. But when you go to a different top level declaration, that's a different scope, right?
Yeah. Uh, let's do this one now. So there are two ways of doing this: folding it or recursion. Which one do you prefer?
Folding it or recursion.
Yeah, because we can just pass the queue to this function and do it recursive until it's empty, for
We
instance.
can't actually do a fold because we may need to add more elements to the queue as we walk through it.
Oh, okay, that's a good catch. Very good catch. I didn't think of that at all. Because there may be the case that we have things nested in even more things.
Yeah,
So in this case, recursion then, right?
right.
Okay, so we're gonna receive the queue. Actually, do you think it makes sense to? No, we should receive the entire compiler. Actually, receive then all of this, and we should just return the compiler and the store again. Agree?
Yeah.
Okay. So and then.
Basically, what this is gonna do is it'll check if the queue is empty. If it is, we're done. We can just return the compiler. If it's not empty, we pop the front item. We do an emit fact argument on that value, and then we call ourselves recursively in a tail position.
Yeah. Okay. By parts though. While you were explaining that, I was copy pasting stuff. Okay. So we match the first thing from the queue, right?
Right.
If it's not there's nothing in there, we just return. If
We
there
just
is something
return.
in there, we need to do something about it. The first thing that we do is saying to the compiler that there's actually you update the terms, right?
We update the terms, yes.
With popping, effectively popping the element that we just got. Then we
Yes.
pattern match on that element, and then here's the catch. What should we do with that
We
element now?
don't have to do that. We can just do an emit nested fact argument, actually.
You're saying? Let me see if I got what you say. Do this, and then emit nested fact argument. You pass compiler in the store and the element, uh, and that's it.
No, and then we need to do a tail call now.
Okay, and then you do emit q fact argument. Uh, ah, uh, of Is that what we are talking about?
It is,
Wait a moment.
and then
There's something wrong.
okay,
There is something wrong with the syntax. Oh, here. Okay. Okay. Proceed. Oh, that was not a
and
joke.
then
I just said.
yeah, and then we have to emit a proceed after we finish emptying out the queue.
Yeah, but we do that after folding the fact arguments on the top level. Uh,
Yeah, after we emit the fact on the top level, we need to call the emit fact argument queue.
okay, there is some sort of inconsistent pattern going on. Okay, anyway, go on. Continue.
Yeah, after we do a fold for the top level, we do the emit fact argument queue, the function that we just
Uh,
wrote.
the Wait a moment. Actually, no. I
No,
said we're gonna pass
it
the
just
entire compiler.
yeah, we're gonna pass the entire compiler.
Emit q fact arguments. That's a little bit of a. There we go. Now we're talking. Here, pass that in.
And then we just do an emit with a single proceed instruction.
Uh, this doesn't require anything.
It doesn't.
So in that case, is that it? No way.
It should be. We may need to mess around with the register allocation a little bit, but worst case scenario, we're just going to allocate registers higher than we need to. That's
Another
not a deal
question.
breaker.
I forgot. Are we settled that this will be a functor and not a variable? Have we checked for that before? I don't recall at
What
all.
is going to be a functor and not a variable?
This thing on it's a little small on the right.
Yeah, no, that's a functor.
No,
It's
no, but have we checked that we are parsing that as a functor correctly and
we
so on?
sh we should be. This is lowercase, so it should parse as a struct, as a functor
Okay,
structure.
let's see if it compiles. Dune exec. How awesome.
Well, it compiles at least.
Yes, but I actually don't even know. Oops. I don't even know what the heck we're trying to run. We're trying to run L2, which that's not what we want to run. We want to run kind of this, no?
Yes.
No, but we should use the example. Where did we test? Okay, never mind. We're not gonna remember. I think we tested the query somewhere, but we didn't commit apparently for some reason.
Did we not? I think we did.
Where is the query then?
It's an L2, no?
Where? Did I forget to
Oh,
pull
it
by any
isn't.
chance?
You might have, yes.
Oh, that would be hilariously bad. Uh, the previous commit was from you. Add code generation for queries. Oh man, I think I didn't pull. Okay, okay. All of this work. Uh, okay. I was able to do that. Okay. That's that's a little bit unexpected. And here it is. Okay. Cool. In that case, change these discard or edits. Yes, I don't care about them yet. Oh, actually, you already wrote this. Well, in that case, let's just go for it. Got worse somehow. Interesting. Okay. It's even more broken now. We have no clue what the heck is going on. This is so wrong though.
It's kind of weird that
Wait a
OCaml has
moment, wait a
exceptions,
moment.
but okay.
Did I just lose everything? No. Okay. Okay, no, I didn't just lose everything. Oh man, I was about to have something. It didn't work at all. So I guess printing time.
It's kind of weird that OCaml has exceptions but no stack traces.
Yes, that's weird. Maybe it's a Dune thing though. Maybe you need to set a flag, but then you may ask why that's not active by default. Yeah, that's a very fair question. Okay, so I guess we should start with adding a print and line um, here. What the heck is going on there? I don't even know. Okay. Oh, I should run the Dune FMT. Okay. Uh, let's see if this worked, because maybe that's the problem. And uh, let's put another one here. Why the heck not? Okay, here and here too, which means that we pass through register allocation, and we definitely passed through that, and then we stopped on code generation. Okay, so declaration, here we are. So let's put something before the fold left eye,
All right.
and something in here, and then finally something in here, and see how far we go. We Wait, what? That's a little crazy, huh? What'd you say?
We went up to 4.
Oh wait, we have an exception of not found, so this is the problem.
Declaration,
I think you can
get
even test that out.
structure. Actually, I think that get structure shouldn't be there.
I think it needs to though.
No, it doesn't. We're going to emit it if it's an argument, right?
Yes, this is the problem. Wait, repeat.
Like
My
the reason
understanding is that we're doing the... Oh, you're right. This get structure happens inside the fold.
yes.
So done, 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 done. Which means we don't care about this guy. Okay, now we
Oh,
went to...
actually, go back to the book real quick.
I'm here.
Ah, okay. There's a label there on the top left. See,
Top left. I
p
don't see.
slash 3 colon, and then there's the instructions, right?
Yes.
I think we don't actually need to put the facts in any particular order, actually.
Wait, but what if you interleave fact and query, and the query is using a fact that it doesn't is yet not uh,
Doesn't
code?
matter, Lemos, because the compilation happens before the execution.
Ah, that's correct. Good catch on that. Anyway, let's go back though. We went to here 5. here 5 means that we did this
And
and
it
we
didn't break,
failed here.
and we failed here.
How? Like, this is definitely not what happened. We are trying to reach an... This is a seg fault. In our language, of course.
Oh wait, it finished compilation.
No, it didn't. Because if it did, we would see here 6.
Hmm.
Agree?
Yeah, we would.
So this is the problem for sure. Like, my understanding is that this error message means that we are... Wait, are we out of memory? There's no way, right?
Tried reaching illegal memory region.
We have 100 in everything. There's no way we're out of memory, right?
Well, we can always just get a bigger computer, I guess.
Well, but this is... Are we have... Do you have to upgrade memory because of this program? Really? That's a little insane, no?
Yeah, there's something weird going on, I guess.
Well, but memory is cheap, as they say. I really don't think that's a problem. Yeah, that's not the problem at all. Okay, so what in here could be causing that? It needs to be de-nested, right? Because this is not doing any add instructions at all. Agree on that?
Uh, yeah, it needs to be the... Yeah, it needs to be that, actually.
Yeah, so I think it's line 185. Don't you think?
Add instruction.
That's the only function in the nested fact argument function that changes memory.
Hmm. Try putting a print just before that add instruction and another one after. You need to put a... yeah.
Uh, oh, okay, so there is an infinite loop going on. And that's why we got out of memory.
Huh. There's an infinite loop going on. That's... Okay,
That's a
we
little
do
sus.
that.
How are we not ever reaching this then? Probably it's a pain in the butt to print the terms.
Oh, actually, I think I see the problem, maybe. Because we use this function to add the stuff to the queue originally, right?
Which function?
The emit nested fact argument, right?
Yes, we did.
But the problem is that it's going to see, oh, we're emitting the instruction for a functor, and then it's going to add it back to the queue.
Ah, we are feeding ourselves.
Which is not actually right. This shouldn't put... I mean, I think we may actually need a third version of this. Well, not third, but... Yeah, one that adds the entire functor to the queue, which we are using in the initial loop to do the top level arguments.
Yes.
And the one that goes in the nested emit queue fact arguments, that one needs to actually put the the arguments of the functor in the queue, not the functor itself.
Mm, damn, but everything else is the same. Agree?
Yep, I agree.
Okay, there are a couple of solutions. Uh, the one that I'm primarily leaning towards is to add a lambda to this as an argument that we're just gonna pass the functor to the lambda.
Actually, that's not quite right. That's not quite right. It needs to step through the arguments, and then if they are variables, actually, can we just do emit fact arguments here?
Wait,
We
where?
can't, right?
No, where?
Because okay, here's the thing. We are already doing something similar in emit fact arguments. Well,
Yes, we are doing something. We are doing the get structures and get values in here.
yeah. The thing is, we need to do basically the same thing, except except we don't have an index. Hmm. Yeah, so it's going to be basically a mix of this and the emit q fact argument nested thingy, I guess. Emit nested fact argument.
Wait a moment. Let's backtrack a little bit. So what you're saying is that we should be able to use a lot of emit fact argument to be this function. What should be in here?
We would be able to if it did not need an index, but it does, so we can't.
Uh, that's hard stuff.
Yeah, the function that we need to call inside of the emit q arguments needs to be like it needs to be something halfway between emit fact arguments and an emit nested fact argument.
Okay, let's do it this way. Let's make it work first, and then
Or
later on, because like this function needs to go away from here. This is like at this point a 200 line function. This thing. So this needs to move away. We need to separate things better. But for now, let's just make, I guess. Actually, first I'm gonna move this to up here because now they are not related anymore. And I'm gonna copy this thing and make the queue nested. Yeah, that's what I'm talking about. Uh, uh, okay. And what I'm gonna copy paste? Which body I should copy first?
mm,
You said it's a mix between nested fact argument and fact argument, right?
right, grab the fact argument first.
Okay. Okay. We don't have an index though.
mm, Actually, I misspoke. We just need a functor from this.
What?
You see the pattern match where we have match lim and then we have a functor clause, right?
Yes.
We need that basically. Everything else we can grab from the nested fact argument.
No, wait. Baby steps, dude. Let's not jump steps. What about this arg register thing?
Uh, well, we can get rid of it. We're not going to use it because we're not emitting arguments anymore.
Okay.
Well, not top level arguments anyways.
What about the if we found a variable in this q nested fact argument?
Okay, if we find a variable, we need to emit unify variable.
Okay. So unify variable, it's this one.
Yeah.
So this, you mean?
Yes.
If we find a functor, what do we do?
If we find a functor, we need to emit a get structure, but we actually need to use the register instead of the arg register now.
Uh-huh.
Uh, then we do, yeah, then we do a fold left, and we can emit q fact argument. No, actually. Hmm.
No, actually. Okay.
Uh, Scroll down a little bit, please.
Yes. This was supposed to be very easy to do. This is rather like we have 4 functions already.
Okay, no, no, no. This is good actually. Go back up there.
Mm-hmm.
Now we can do a left fold using the emit nested fact argument.
Okay, but that's a problem because this function doesn't exist in here, which means that I should put it back up there. So all the way here. God damn. Okay, so before we go through each one of these 4 functions, let's actually see what the heck is going to happen. Okay, that's pretty good sign, I would say. Go. Okay.
Recursion lemos, it's amazing.
Not in SQL.
I mean, what is amazing in
The
SQL?
lore, the lore. uh, okay. Get structure f1 0. Well, a is our axis, so it doesn't matter. Then we have a unified variable with x7, which is a little sus. But I think it depends on the way that we're folding stuff.
Yeah.
So let's remember, 4 is actually 7. And maybe
Okay.
7 is going to be 4. Who knows? Then we have another get structure, h2 x1, correct. Unify variable x6, then unify variable x8. Man, we need to keep track of the mapping of the numbers. Uh, then get value on 6, which was the first unified variable, which is this one, so it's correct, and 2, which is a3, correct. Then we have another get structure f1 with x8, which is the same as this one, so it is correct. Uh, then then we have a unified variable x9, which is supposed to be x7, I guess. Uh, then another get structure x9, which is the same as the one before, and then proceed.
So it is correct, but the register allocation is
Kind of
inefficient.
sus.
Yeah, no, we may need to tweak it a little bit because we're probably allocating more registers than we have to.
But why?
Because we're allocating registers for the arguments redundantly because they already have registers.
So we should not jump the arity in the beginning. Is that what you're saying?
Mm, we should not jump the arity in the beginning. Yeah, probably not actually.
Okay, let's remove that. Okay, so I guess that I'm gonna put 0 there. And let's see what the heck happens. Okay, that didn't blow up, which is a good sign. Let's go. So the beginning is the same. Then unify variable x4. That's a little sus, because I would expect this to be x3. But okay. Then we have h2 x1, which is a true. then unify variable x3. Okay, so now 5 is 3. Then unify variable x5, so 6 is 5. Then we go from 5 to 3, so it's something to 2. 5 is actually 3, so this is correct. Cool. Then then get structure again, f1, 6, but our 6 is now 5. Okay, that's correct. Then unify variable x6, it's 7 there, it's okay. But this needs to be on the A as well, and then we have a proceed. Yeah,
I think this is correct. It just happens that in our implementation, 4 and 5 are flipped, but that's not a big deal.
yeah, but I think that's because I think we talked about this before. This is because of the folding strategy.
Yeah, it's because of the order that we label the variables. It's not quite the same as the one that the book is using.
Okay, let's actually make sure the queries are still uh, working correctly. And let me also remove the prints. Oops. Why do we have this?
For debugging, I guess?
Yeah, but usually we remove those after we're done with them. Okay, let's actually pick this one, and this is still L1, so it's fine. Uh, we don't have comments, so goodbye.
J Diesel doesn't have comments.
Okay, let's see. So what the heck's going on? So it's already wrong, but it's wrong because we made the change to the.
Queried using undefined predicates.
Wait, where? Oh, it's because
Oh, right. We
these.
need to. We need to. We need to. We forgot. We need to save the memory location when we start allocating the emitting the instructions for the fact. We didn't do that.
You need. Wait, repeat. You need to do what?
We need to save the memory location before we begin emitting the instructions for the fact.
Why?
Otherwise, we don't know where it is and we can't jump to it.
Okay, let's do that a little bit later. Let's just see if this is correct, because then I can do a commit.
Okay.
Do you remember what the heck did we change? Like, we made a very bold move, which is to say that the book is unnecessarily redundant, which I think is gonna bite us in the butt later.
The first put variable is a set variable instead.
Okay. Then we do put structure, which is correct. Then we do set value, in which we do 0, but it's 4. Then set variable on 3. So 0 is 4 and 3 is 5. Then put structure f1 a3, which is okay. Then set value again x5, but 5 is 3. Yes. Then we do a call, which is also correct. Okay, I'm pretty satisfied with this.
Yeah, before we do the commit, go to the declaration, the fact, the thingy.
Yeah. Okay, which one? This one.
Yeah, that one. You see, generate code, compile,
Oh,
register a lock,
this is the main thing. This is not code generation. This is compilation.
compile. This is not code generation. Yeah, no, code generation, code generation.
Okay, code generation then. The it's this one.
Yeah, you see, in the case below, before we start emitting codes, we update the functor table. That's what we need to do.
Oh, okay. Uh, And how exactly are we planning on doing that?
We need to grab the
Everything else?
yeah, we need to grab the name and arity from the head.
Yeah, everything else. And I'm guessing that in here, with
Functor table. Yeah.
what is this supposed to change in return in terms of? Yeah, this is not going to change anything, but this reminded you that we needed to, right?
Yeah.
Okay. Okay, so now let's do a commit. Okay. Uh, um, Another question.
Okay.
Uh, Now that we have, oh, actually, we should see if L2 is still not broken. We definitely should test for that before we say that we have any success, because it doesn't matter that if we did all of that, but we broke something in the on the way. Oh man, do you remember,
Oh, it's
Marin?
because you got rid of that print line that you asked what it was for, right?
Uh, I don't see. No, it's just that was just I removed the printing of the registers, right? But after parsing and before printing of the store, we were printing the register thingies, right?
Hmm.
Do we need that to assess for this?
Aren't we?
Aren't we?
Hmm. I thought we were printing the registers after running the program as well. Are we not?
After running the program, you said. We we do run the program. I don't think we are. Yeah, I don't think we are actually. Oh, but this program doesn't have a query. I removed it.
Oh, right. Then it's not gonna run anyways.
So uh, this is the query, right?
Yes. Although that query is not gonna work because there's no P3 in this program.
No. Okay, so let's make one. That's actually a good question. What happens if you have two predicates with the same uh, name f here?
As long as they have different arities, it should be okay. If they have the same arity, then we have a problem because I don't think we're handling that case.
No, yes, but my question, my primary concern was, are we handling overloading out of the box? Like,
We are. We are.
okay, that's kind of cool. So what type of things should we have in here? So A, B, C, then what? Then just that it? That's it?
No, put a colon minus there. And just do, I don't know, just for fun, do P with two arguments with AB, and another one with two arguments with BC.
Okay, I'm assuming this is not useful as well.
We do need that actually.
Oh, I see what you're doing. You are basically piping the PAB to QAB, which is a fact, so that's fine. Then you're saying, oh, but these are all variables, right? These are not like this is true for all variables, right?
It is.
Okay.
It's just trivially true.
Yeah, and then this the same thing, which is also the same case for R. R is correct for well anything. I'm not very well versed in Prolog. What happens if I do this?
Uh, it's only going to succeed if the two arguments are the same in that case because it's going to try to unify them.
Yeah, I really miss this in other languages, so it's fine. It's awesome that Prolog has that.
Although there's one more thing that we're missing actually. We haven't implemented proceeds in the evaluator.
I think we did, but I think it does nothing. Yeah. Oh, actually, no. There is a function.
There is?
Yeah.
Oh, there is. We do have it. Okay. Then it should work, I think.
Okay, but I think we're still missing H and F though.
We are not actually, because those are not predicate calls, they're just functors.
I don't follow. Isn't it going to try to find this functor definition somewhere?
No, it's just going to treat it as data.
So this is the entirety of B.
This is the entirety of B, yes.
Okay. And C is the entirety of this.
Yes.
But if I added an H here, like this, and did it like this, that would say that Z would become B and W would be D.
Yeah. It's going to unify those variables.
Yeah, so then we don't want that. Okay, what should be the output of evaluating this program? Because we didn't do any std output with anything.
That's a very good question, Lemus.
Okay, so we don't know what the heck is gonna happen.
It's going to run. Hopefully it's going to terminate.
Stack Overflow.
Stack Overflow.
Uh, Wait a moment though. That means uh, that if I go down here and I do a print uh, end line with like about to evolve. Okay, the first instruction blew up, but compilation and code generation, registry allocation, all of those things apparently are fine. But here's the kick. This is finally the time in which we are debugging these functions.
Yep.
So they may be wrong. In multiple places, in fact.
They may be, yes.
Okay, let's start. So, uh, as far as I can tell, we pass a program counter query thing, right? Where are we doing that?
I think it's part of the compiler outputs, no?
Part of the compiler. Let's compile. That's not what I want. Oh, here it is. Okay, so we grab something called ds, which I have no idea. What is that? Wait, what is the output of this? No, we don't pass that as an output. You see?
Return cells and a store.
Yeah, but entry points. Entry.
All right, we need to we set that when we see a query.
Yes, here it is. So we grab the entry point. We see if we have not encountered, because maybe we're gonna have for now this is we're gonna make the conjunction thing later, but for now this is an error.
Yeah.
Which is perfectly fine. Then it's inside the compiler. So are we passing this to anybody by any chance?
I think we are.
Okay, so here it is. This is the entry point. Then we try to find the entry point inside the functor map. If we haven't found, we're gonna say that the query is trying to use something that was not defined before.
Yep.
Otherwise, that means that there is an entry point, and then we update the p register with the entry point definition, and just call it a day. Call it a day. Pass the functor table and the stacked machine to it. So the machine itself knows how to start the program. This computer knows how to start the program. The question now becomes, are we using this information anywhere? The answer is yes, because here's the p register, which is the thing that we just updated, right?
Yes.
So, tricky question. Uh, should we print them? Maybe we should print the p register. The answer is how easy it is to do that. I'm not entirely sure.
P-register is a number.
Yeah, but it's not a number actually. It's a type.
It's an address.
Uh, yes. P register. Oh, it is a number actually. Okay, but in that case we should be able to do show. How do we do that? It's show maybe. Ah. Magetta, you there?
Yeah. What?
How do I stringify an integer?
Uh, in OCaml,
Yes.
integer choose string underscore choose string
Integer.
choose string.
No.
No,
True.
underscore choose, yes, choose string.
Like this.
It should be.
Isn't it maybe integer uppercase dot toString?
That works because you have in the module, but there's a function for that too. Or is it string of integer?
That might be the case. Actually, that's probably the case because naming conventions, right?
Well, there are no conventions actually. Int, it's of int numbers. Oh, it was int to string actually.
No. Okay.
I
Thank you,
mean,
Magetta.
both work, but the
27.
module also works, by the way.
The module also works. That's good to know. So, Jesus, how are we gonna know who is going to count? uh, that's cool. Is there any trick? Because it's kind of a positional thing, right, Marinho?
Yeah, it's completely positional.
Can we do a trick to know exactly what the number should be? Isn't it just a matter of putting this at the beginning?
Yeah, that should work.
Okay. So it should be 0.
It should be.
Uh, okay, we have our first bug, believe it or not. The order matters.
Huh, it failed when we did... Huh. Why is that? Is it an off by one? Is it a freaking off by one error?
Uh, that's
Because the instruction... Hmm.
let's backtrack a little bit. Why does the order matter?
It shouldn't, actually.
But it does. It completely does.
Okay, go back to the code, add another print, and this time I want you to
Where?
print the instruction that we're about to execute.
That's okay. We need to add some ppx because instructions are not printable. Oh no, wait. No. Yes, no. We need to do that. So add that. There we go. So you want to print the instruction. Uh,
Yeah. Well, we can print the cell as well. That also works.
no, printing the instruction is actually easier. So it's here. Print and line. And then I have absolutely no recollection. Is this machine show? Uh,
Instruction.
no, but I think that's not how that works. Man, it's so freaking rare that we have to do that. I keep forgetting. How do you do that?
Can't you
Every
just
time.
do show or something?
No, I think it's instruction show. Ah, or something like that.
But instruction is not a module, it's a type.
That is true, but we have a thing. Okay, so I need to go into cell. That's true. So cell,
Cell dot
uh, and then show. Wait, what? No, this is not correct. Yes. Okay, that's how you do that. So you want to know the first instruction. Okay, so it's correct. So it starts by doing set variable, which it is in fact the first instruction. Then it goes to put structure, which is the second, which is also correct. Then we go to set value, and then it blows up.
Finding get register and then not found.
I'm gonna bet the set value is calling get register. Yes, and this is failing.
Get register register computer.
Yeah, and then we go to get register, which is the function that we implemented last time. The prints are still even that are even still here.
Hmm.
So ideas. Can we look at the memory and judge if this should work or not? Or is this crazy?
We can try looking at the register map, right?
Oh, the
That's
one
an
that I
option.
removed. Sure. So where did I remove that? It was here. Here it is. Uh,
Not in the compiler though. We need to check that in the evaluator now.
the evaluator doesn't have registers.
What do you mean?
Yeah. Uh, as far as my understanding goes, these registers have nothing to do with the register map that we got from the compiler. We don't pass them along.
But we just need to print the X registers. Like they're on line 47, no?
No, that's what I'm. Wait, am I crazy? Let me just check a little thing. Maybe I am crazy. Uh, so you do all those. Oh, here it is. So you get the compiler and that, and oh, there is an initial computer. No, but that's what I'm saying. You see? So the compiler has registers inside it. Remember?
Yes.
These registers are not passed along to the machine at all.
But the machine has registers and the instructions interact with the registers.
Yes, but maybe that's the problem. You see? Maybe what we should actually do is grab the X register from the compiler and pass them to the X
No,
register of the computer.
no, Lemos. We shouldn't do that.
So then I'm confused because these registers that I'm about to print here, they don't
We need
make
to we
any
need to print
sense.
the registers from the compute from the evaluator, Lemos. The live registers that are being manipulated by the program.
Ah, okay, so it was not what I thought that I removed before. Where do you want to print them? At each point, which point? Beginning,
Let's
each instruction,
see. Let's try to put that at the beginning of the get register. That's
beginning
the
of the get
instruction that's
register.
blowing up, right?
Yes. Okay, here they are. Uh, so it's gonna be probably machine dot show registers. If I don't remember that function from before. Did I implement this function here? Show. Oh, here they are. Uh, is it worth to copy paste that to here? Because this is a IM of cells. And what is this? What the? No, I don't want to do that. Wait, IM in OCaml source code. I didn't know that was a thing,
You
but
can
okay.
jump, yes, if you are an LSP.
Okay, I didn't know that. This is a bat map. Okay, so these maps are not the same, so I can't just copy paste. Question: can we derive this thing?
We may be able to.
Maybe able to. Ah, okay. I'm not gonna. Let's go with the what we know it works. Let's just copy this thing. Go here and add this function. Uh, so let's grab this type.
Man, I just made a very trashy SQL query.
You're professional.
I probably am, man. I probably am.
You probably are. So this is gonna be IM. So this is a 2sec. We need to go to batteries and discover how to transform the IMAP into a sequence.
Hmm. Let's
There.
see.
Ooh. Are you telling me there's no way to do that? That's gonna be horrendous if that's the case. Oh, wait a moment. But that's because I'm doing a fold left. There's no fold left for it. There's only fold. Okay, so maybe that's the problem? Maybe.
Hmm.
Oh, no, okay, I see what I did. I grabbed the bat map, I converted to a sequence, and then I used sequence in batteries to fold it.
Let's see.
Instead of doing that, what we can do is just fold with a string. What do you say?
Fold with a string,
As the accumulator.
like concatenating.
Yes.
I guess that works.
Okay, so that will be fold. Uh, what's the order? Then it comes the function, then it comes the map, and into x0. So yeah, the accumulator comes here. Uh, and then our lambda needs to have an index, which I'm assuming is the key. It has a b. What the heck is the what the heck are those a's though? Oh, this is the
Those.
accumulator. This is the value. This is the key. Okay, I see.
That's a very
Value
weird order, but okay.
and acc. Then we do uh, acc uh, concat with the key, which is going to be string of int key equals, and then we have the value. The value is a cell. Theoretically speaking, I should be able to do cell show yes, and then value, and then call it. Wait, why is this wrong? Oh, this doesn't receive a tuple. Okay, that works. Now we can go here and say, actually, what did I name that? Unbound value, machine show registers. What? Am I confused? I think I'm confused.
Hmm.
Oh, we have a show function for the story. Let's put this there. There we go. X. Uh, I'm gonna guess that LSP is just going crazy.
I am
Yes.
retarded.
Uh, wait, did I save this? I did. I'm not printing anything.
Hmm.
I'm so confused right now. Oh, no, wait.
No, you
Uh,
are, I think.
I am, where?
About to eval 0, set variable
Oh, it's
machine cell
empty.
x0.
That's the problem. It's empty. The X registers map is completely empty.
Well, it shouldn't be because we just did a set value.
Okay, so the implementation of that is incorrect. Set value. We did a set value variable first. Let's actually, which ones do operations on the X registers? Set variable does that? Okay, it does. Wait, it does it? This is okay. This is nonsensical because this we're not changing it. I don't know why I did that. Okay, put structure. Are we doing manipulation of the thing in here? I'm gonna bet no. We are. We aren't. See, Marine?
We should be though.
What the heck is going on? Did we just slapped on the spot? What happened? Well, at least we are debugging this thing.
Yeah. Hmm.
Okay, so what is the implementation of put structure? And why we're not touching
Uh,
registers?
Give me one moment.
Okay, here it is.
Uh,
Yes, we're not touching registers at all. Oh no, yes we are. Where? Oh, here it is, Marinho. We made a
yeah,
function
put.
called setRegister. And this is the function that supposedly will write and update registers.
Okay, so computer with X registers, adding index of register.
Yeah, but before we do that, let's actually do a double check. Are we doing set? Yeah, we are doing set register and set variable. What should be the behavior on the first set variable of the program? When doing a set register, I mean.
Uh, well, in this case, we're calling it with an X register, right? So we should add it to the register map, and we should add the the cell that we passed as an argument. Like that should be the value of the register after the function returns.
Yeah, but let's see if we're actually doing that. Okay. Okay, that's actually wait. That's a lot of stuff. Oh, so some wait. How can we have that many? That's a very confusing. But okay. Because, dude, we are doing more stuff now. Agree?
Yeah.
How is that possible? I'm running the same program. What? You see, this was failing.
This is failing, yes.
Then we didn't change shit, and now we are going all the way down. Look at how much more stuff.
About to eval 2, about to eval 3, about to eval 4, about to eval 5.
Wait, so we actually did a bunch of stuff. In fact, how did the output of the program change though? I'm so confused.
Uh, Try putting parentheses around the line 9
Parentheses.
and get rid of that print end line real quick.
Hmm. Same thing.
About to eval 11, 12, 17.
No, we're not going to be able to make sense out of this. This is just gibberish. We need to have a better strategy for debugging this. The about to evolve is every single step. We
I
print
don't
about to evolve.
I don't think we need to print that though,
Sure.
do we?
Well, before we just want to know where are we having the bug. Then we are
Okay,
printing the register immediately. So the numbers are the registers. Well, the program counter, I mean. The numbers are
yes.
the program counter. Then we print the instruction. So like this, you see.
When we print the instruction,
Yes. Then we were printing the set register. If you call set register in your implementation, then we're gonna call you. If you don't, we're just gonna go to the. We're not gonna see, as in this example here, for instance.
Okay.
So how do you want to do this? Where do you think it's going to be traceable? Where the heck we are going with this?
Wait, go down to the bottom of the print. Unreachable get value.
Let's try to see. This is okay. So we reached get value then at some point, and we did a match doing should get registers, and we got the unreachable.
Hmm.
Okay, let's see how get register works. Um, this is going to return a cell T.
Yes.
The last thing we do before failing is doing finding in get register. So we found something, a temporary register. We found it, return that, but we're calling should get registers in sequences, right?
Uh, oh, I think I see what's going on.
That's crazy, but okay.
Go back to the pattern match where this is failing. Unreachable. Yeah, see, if you look at the print side by side with this, yeah, open the terminal. Yeah, there we go. So we have the registers there, right? We have a bunch of references, which are logical variables, right?
Yes,
But then the get value expects both of the registers to contain addresses, and otherwise it fails.
yes.
But with the registers that we have at this point in the program, if you look at the print, we only have references, and references are not addresses, so it's always going to fail at this point.
But doesn't that mean that either this pattern match is wrong or the code that is generated, the compilation is wrong?
It could be that the implementation of the evaluator is wrong as well.
The
Well,
implementation of the
yeah, this pattern
evaluator
match,
is
this pattern
wrong.
match. That's the first
Oh,
option actually.
289.
Yeah, we need to. Huh.
Yeah, but the question is, what should be in here at this moment, when you do these should get values? Should we have references in there or addresses? I already forgot the difference.
An address is basically a raw pointer. A reference. Actually, I'm wondering, maybe we should only have addresses in the registers, maybe?
No, but I don't think that's how it works though. I think we have cells inside the computer after compilation that have references inside them.
Yeah.
So that's the thing. Are we do we have any address in here?
No,
We
we actually
don't.
don't we actually don't emit references explicitly. They are constructed during the execution of the program.
Oh, so you mean these ones? Yeah, these ones, set variable for instance. And do we have any address? The answer is
Not really, apparently.
on get structure. Oh, we have a bunch of addresses actually. But I'm actually not sure get value should ever have addresses now. Maybe we should go with references in here.
Yeah, we're using addresses internally, but they shouldn't actually be visible from the execution of the program, I don't
What
think.
the heck? Line 135 pattern match failed. What does that mean? Oh, is this the... Yeah, this is the crazy function.
Oh
Okay.
yeah, that's
Okay, so that means that these are also references probably.
probably.
Okay.
Although
Are we gonna deprecate addresses?
although references they have a slight problem because references they can be they can point to other references, which I'm not sure. Oh, I'm not sure if that's actually a problem, but okay.
Wait, there's not an address or a reference in here.
It can have, let's see.
No, you can have anything. You can have any of those, but I think we made that function make with the assumption that this will always be an address,
Hmm.
which apparently I think we just got wrecked.
Yeah, we will have to revisit that actually.
Yeah, but how much time? Oh, 2 hours on the clock. Okay.
Well, the good news is we can finally debug the evaluator, which was our goal like 2 or 3 sessions ago.
Yeah, we can finally see if all of these hundreds of lines of code are actually correct. I think that's pretty good, honestly.
Yeah, I think we can wrap up the session and then Mageta, after we finish recording, Mageta can do his announcement, idea,
Yeah.
whatever.
I'm gonna click